energy consumption and costs of appliances. So heating and cooling make up almost a quarter of the home's energy use in Australia. And the biggest user of energy in Australia are the hot water systems. So first of all, we're going to look at a very quick examples. How much energy is used in kilowatt hours when a 100-watt light bulb is on for 5 hours? So what we're trying to do is we're trying to calculate the energy used. So it's a good idea to write down what you're trying to do. And I know it's 100 watts, and I'm going to multiply that for 5 hours. And so I get 500 watt hours. Now the question asked me to put this into kilowatt hours. So to change to kilowatt hours, I'm going to take my 500 and I'm going to divide by 1,000 based on the previous work. So that's for kilowatt hours. And if I do that, I get 0.5 kilowatt hours. To calculate the running cost of an electrical appliance by multiplying the power used in kilowatt hours by the cost of electricity. And that's what we're going to be looking at. So I've put here in a box, running cost equals power used in kilowatt hours multiplied by the electricity cost. And this is how our power bills get created. So Bella spends 1.5 hours a week ironing her clothes. She uses a 200-watt iron and the cost of electricity is 0.230 200. And that's exactly how, if you look at an electricity bill, electricity is quoted to 6 decimal places. Calculate the cost of using the iron in 1 year. So the first thing we need to know is how much power am I using in 1 year? So to do that, I know that my iron uses 2,200 watts. It's on for 1.5 hours a week, and I know that there are 52 weeks in the year. So multiplying that all together, I get 171,600 watt hours. And I'm now going to divide that by 1,000 to change it into kilowatt hours. And I get 171.6 kilowatt hours. So now I need to know what the cost is going to be. So I know how much power I've used over a year, and I need to multiply that now by the cost of electricity. And when I work that out, my calculator says it's 45.8613 and so on. And we all know that money needs to be to 2 decimal places. So that's 45.86, $45.86. Now the next thing we need to know is that all household appliances now display an energy rating, and they all look like this, and you would have all seen that. So obviously you know that the more stars, the more efficient the estimated costs of the energy used in kilowatt hours will be. And on here, it gives you an estimation of what the cost of running that appliance is in kilowatt hours. So let's have a look at some examples. But before we do that, we can just read through this. Water heating accounts for 30% of energy usage in a house. There are 2 types of systems, storage and instantaneous. And people use solar, some people use heat pumps, natural gas, and off-peak. 77% of electricity in New South Wales homes is used for lighting. And the main types of bulbs are incandescent, which are traditional, which are now outlawed, or halogen downlights, or compact fluorescents and LEDs. So if we look at this, an incandescent bulb and the equivalent compact fluorescent lamp are used for 5 hours a day. And we're going to compare the running costs of both of these. Now, this incandescent bulb is now really obsolete, and because they were found that they were producing light and a lot of heat as well. So they were actually costing us a lot of money. So it's worthwhile to have a look at this change. So for the incandescent, the electricity used in 1 year is 75 times 5 times 365, which is 136,875 watt hours. And I'm going to divide that by 1,000 to make it into kilowatt hours. So I get 136.875 kilowatt hours. So now the cost of electricity is 136.875 I'm going to multiply that by the cost, which is 0.218500, which is in the question. And then I get 35.3274, blah, blah, blah. And I know that money has to be 2 decimal places, so I get 35.33. Now for the compact fluorescent, electricity in 1 year is 10.5 times 5 times 360. So I get 19,162.5 watt hours, which is 19.1625 kilowatt hours. So I divided by 1,000. The cost of electricity used is 19.1625 times by the cost, 0.258100. And I get 4.9458, etc., which is $4.95. So you can see why we have moved to the compact fluorescent, because they cost us significantly less money. I've also put down a point here that says washing machines, clothes dryers, fridges and freezers, televisions and dishwashers and other appliances account for 25% of household bills. So looking now at example 4, it says calculate the lifetime running cost of the following televisions using 30 cents per kilowatt hour as an estimate for the cost of electricity and assume that the average lifetime of major appliances is 10 years. So if I was going to look at this, for my Sony TV, if I'm going to look at my lifetime running cost, what I'm going to do is I have the energy consumption is 319 and it costs me 30 cents, so that's 0.30 and 10 years. And so you can see that over 10 years, my television is going to cost me, apart from what I bought it, an extra $957. And so I'm going to do exactly the same for the next one. So what you could do is pause the video and see if you can do it without me. So the lifetime running cost is going to be, in this case, same thing, 388 times 30 cents times 10 years. And I end up with this television costing me $1,164. Now, the other thing that uses up power is the fact that all of our appliances nowadays have a standby mode. And that standby mode means we are still using power even when the television or anything like that is not plugged in, like the cordless phone. So let's have a look at doing this last question. Find the power consumption of a cordless phone on standby. Oh, so what is the standby mode for a phone over a year if the electricity is charged at a rate of 28.05 cents per kilowatt hours? So power consumption is equal to 3 times 24 times 365, which gives me 26,280 watt hours. Which I'm going to divide by 1,000 to make 26.28 kilowatt hours. And therefore the annual cost is going to be that 28.28 multiplied by the cost, which is 0.2805. So remember to change that into dollars. And I get 7.371, etc., which is $7.37. So remember, that's just one appliance that is on standby mode, and you might want to think about all the appliances in your house on standby mode and what that might end up costing you. If you've got any questions, you know where to find me.